Hello everybody and welcome to my channel. In this video I will be talking about subnetting. When we talk about subnetting, so many people they are afraid from this concept. However, it's very simple to understand, and I think there are some basic concepts. Once you master them, it will be very easy for you to make subnetting. So let's dive into it. So basically, let's agree on some concepts. First, the IP address consists of 4 octets. Okay, 1 here, 2, 3, and 4. Okay, so this part we call it octet. Octet in Greek it means 8. Okay, so each octet will have 8 bits or 1 byte. Of course, as we know, 1 byte equals to 8 bits. Okay, and here I have a demonstration. So like 1 byte equal 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. So the IP address consists of 4 octets, and each octet equals 8 bits, or they call it 2 nibbles. This concept or this expression is not used anymore. Mostly they use bytes. So 1 byte is 2 nibbles, and the 1 byte also is equal to 8 bits. Those are basic concepts, you need to know them. Okay, so since the IP address consists of 4 octets, and each octet is 8-bit, so come with me, let's do the math. It will be 8 by 4, so it will be 32 bits, okay, which is 4 bytes. Now, there is some important also principle we need to remember always, which called bit weight. Okay, so this is an octet, okay, and in this octet we have 8 places, okay, or 8 weights we call them, bit weight. So they are going to increase from right to left. So from the right it will be 1, 2, 4, 8, 16, 32, and 64, and then 128. This one we call it the least significant bit, LSB, and this one we call it the most significant bit, or MSB. As I said, if you go from right to left, the weight will increase. Basically, this is 2 to the power 0, which is 1, 2 to the power 1, which is 2, 2 to the power 2, which is 4, 2 to the power 3, 8, 2 to the power 4 is 16, 2 to the power 5, 32, and 2 to the power 6, which is 64, and 2 to the power 7, which is 128. So starting with 1, ending with 128. This table is very important for anyone who wants to practice subnetting, because this table will be like with him all the times. Okay, so let's dive into examples. I have here an example into binary. So for example, we have this number in binary 1 1. By the way, this one here is same this one here. Okay, but here we will be putting ones and zeros. So here we have 1 1 0 0 0 0 0 0. Okay, so we count only the places where they have 1. Okay, zeros they don't have any value, because here it's 1 multiplied by 128 plus 1 multiplied by 64. Okay, so the sum of these two is 192. Okay, let's go to the second octet. 1, which is 128 multiplied by 1, which is 128. This is 0, so 0, it has no value. 1 multiplied by 32, because the weight of the third one is 32, so 32, and 8, this is the weight of the bits, so total will be 168. Those are easy to calculate since this is only 1, so 1 multiplied by 1, which is 1, and 1 multiplied by 1 also is 1. So we have the IP address 192.168 dot 1 dot 1. Okay, this we call it the decimal notation, and this one we call it the binary notation. Also, you can write it in hexa notation, hexadecimal, but it's not so much used. The one are mostly common used are the decimal notations. So we have our IP address, which is 192.168.1.1. Okay, we convert that from binary to decimal. Okay, now in order to know about subnetting, we need to know one thing. It's called the net mask or the CIDR notation. Those two are different terminologies for the same concept. What I mean by that, when you see a IP address and it's ending with /26, okay, so /26. So this means that the last 6 bits are going to be for host, and the 26 bits are going to be for network. Okay, basically it's gonna be like all 32 minus 26. Let me write it down here. So 32, which is the total bits of the IP address, minus 26, which is the CIDR notation. This will be 6. Okay, 6 bits. So those we call them the host bits. Okay, and the 26 we call them the network bits, or portion they call them. Okay, so let's go for an example here. We have an example. We have an IP address here, and they are telling us to find the network address, the broadcast address, find the first usable or valid host, and the last usable or valid host. Okay, so this IP address and /26, and then as I told you, we subtract 26 from 32. Okay, will give us 6 bits, and those 6 bits, they are where all the work is done. Okay, those are very important bits. We need to pay attention to them, because by doing some operation we will be able to get the network number, the broadcast, and all the other requirements. So the first thing we will do when we are given a question like that, we will write the IP address in binary. Okay, so this 172.16.5.32, we just represent this first octet. This is 172, this is 128, this is 32, and this is 8, and this is 1. So if you do the math, it will be 172. And then we have 16, which is very clear. It's only this one, 16. And then we have 5, which is 101. Okay. And then we have 34. Okay. This is 32, and this is 2. So 34. And then we will write down the net mask. Okay. What is the net mask? The net mask is simply all the bits. The 26 bits are ones, okay, and everything else is 0. So all the host bits are 0, and all the network bits are all ones. It's like this by default. You just have to write that all the network bits are ones, and all the host bits are 0. So in this case, the network bits are 26. Okay, so we put them all ones, 26 ones, and we have also 6 zeros, because those are the host bits. Okay, now the second thing to do, we will make AND operation between those two numbers. And for those from you who doesn't know what is AND operation, it's very simple. I put for you here a table. Okay, so this table showing you, of course, because here you have only 0 or 1. You don't have any other option. In the binary, it's always either 0 or 1. There is no third option. So the operation will be only between zeros and ones. So here, 0 ANDed by 0, the result is 0. 0 ANDed with 1, the result is 0 also. 1 ANDed with 0, the result is 0, and 1 ANDed by 1, the result is 1. So all three, okay, here the result is 0, and only this 1 ANDed with 1, the result is 1. So this table basically is the same the one above. The only difference that I calculated the results. So this is the result of ANDing the first column or the first row with the second row. I ANDed them just as I told you. For example, 1 ANDed with 1 is 1 here. 0 ANDed with 1, 0. 1 with 1, 1. And so on. Okay? All of them. And here I highlighted the last 6 zeros because as I told you, the last 6 zeros will have all the, the operations on them. Okay, so once we ANDed those two, the IP address and the net mask, this number will represent our network number. So we got our first answer. Okay, we write it in binary and then immediately we convert it to decimal. So this is our network number, 172.16.5.0. Very easy, piece of cake. Okay, and then in order to get the broadcast number, the only thing we need to do, okay, we just switch those last 6 zeros. See, I will highlight them with red. We will switch them to ones. Here we go. Okay, and we will get the value in decimal notation as well. So it's very clear, 172.16.5.64. As simple as that. Again, the last 6 digits or the last 6 bits, which we got them from here, if you forgot, 32, the total number of bits for any IP, minus the CIDR notation, we will get 6 bits. Okay, so those 6 bits, we will switch them from zeros to ones. We will get the broadcast number. And then we will have a golden rule. Any one who wants to make subnetting must remember it. It says 2, okay, to the power of n, and n will be this one. 23 minus 26 equals 6. 6 bits again. Our famous 6 bits are appearing here. So n is 6 minus 2, 2 to the power n minus 2 equal, I'm just substituting, 2 to the power 6 is 64 minus 2, so 64 minus 2, 62 hosts. So in the question ask us number of hosts, so 62 hosts. This is without the network number and the broadcast number. If you want the total number including the network number and the broadcast number, so you don't subtract 2 from this. You just get 2 to the power n and you will find the number of hosts including network number and the broadcast number. So those two are broadcast number and network number, because usually they are not included with the hosts, usable hosts, let's say. Okay, what we have left is very simple. We need the first valid host, which is obtained by adding 1 to the network number. So our network number was this, okay, 172.16.5.0. we just put 1. We added, or let's say we went 1 level up, so the next IP address is .1. So this is the first usable host, and the last usable host will be the broadcast number minus 1. Okay, so the last one was, or the broadcast number was .64. We just minus 1 from it and we got the last valid host, which is 63. Okay, so this video was about the basics of subnetting. In the next video, hopefully, I will be giving you a very easy way about how to make subnetting. This thing so far, it's not called subnetting, it's called like basics of subnetting, to know how to calculate the network address, the broadcast, and everything else. So the next video I will be talking about a very easy way how to make subnetting very easily. So I hope you enjoyed watching with me. Thank you, and see you in the next video.